All right, so I bet you're joining us with this deep dive because you've heard of this transfusion model everyone's talking about in the AI world.
Oh, yeah. Definitely making some waves.
And we've been looking at the research paper ourselves, and there's a lot of cool details in there and some pretty impressive images they've included as examples.
Really interesting stuff.
But what really caught our eye is this idea that transfusion is like a new breed of multimodal AI.
Right.
It can work with different kinds of data, like text and images, but in a way that's more integrated than we've ever seen before.
Yeah, that's a really big deal because right now most multimodal models, they either try to stick together separate models for each type of data,
Oh, that makes sense.
which isn't very efficient,
Yeah.
or they try to take images and simplify them, turning them into tokens like they do with words.
Mm-hmm.
But when you do that, you lose a lot of the information, the richness and the detail of the visual information.
It's like trying to describe a painting using only a list of colors.
Exactly. You just lose all the nuance and the artistry. But transfusion is different. It manages to handle both words and images within one single model
Wow.
without sacrificing the details
Yeah.
that make those images so, compelling.
So how'd they do it? The paper mentions using this cool combination of language modeling and diffusion.
Yeah.
Are those techniques we've heard of before?
You probably have, even if you don't realize it.
Okay.
So language modeling is all about predicting what comes next. Like when your phone suggests the next word as you're typing,
Oh, yeah.
that's language modeling at work.
Makes sense.
And diffusion is the tech behind all those AI art generators that everyone's been using. The ones that create those crazy images from just random noise.
Yeah, those are pretty wild.
It is pretty cool stuff.
So they're basically using techniques that have already been proven to work well.
Exactly.
But the real breakthrough with transfusion is that it can do both language modeling and diffusion with just one model.
Yeah, that's pretty impressive.
Yeah, it really is. It shows just how far AI research has come in integrating different capabilities.
For sure.
So let's dive a little deeper. How does this transfusion model actually work? Can we get into the nitty-gritty?
Absolutely. So picture this at its core. Transfusion is built around what's called a transformer.
Okay.
And this is a specific type of neural network architecture that's become really popular in AI, particularly for processing language.
Okay.
And it's designed to understand the relationships between different parts of the input, kind of like how we do when we read a sentence.
Uh-huh.
But we're not just dealing with sentences here, right? We've got images too.
Right. So how does transfusion represent those?
That's a great question. So text is still processed as tokens,
Okay.
which are basically like numerical representations of words.
Okay.
But images are handled differently. They get converted into what are called continuous vectors using something called a variational autoencoder.
Yeah.
Or a VAE.
A VAE. I think this is where some of our listeners might start to feel a little lost.
That's fair to say.
Yeah.
So think of a VAE like a really smart compression algorithm.
Right.
It takes the complex visual information from an image and kind of boils it down into this more compact format that the model can work with easily.
I see. So we have these tokens representing words and vectors representing images, and they all feed into this transformer engine.
Right.
What happens next?
This is where the architecture of transfusion gets really interesting.
Okay.
It actually has special components called encoders and decoders that are specifically designed to handle text and images.
Gotcha.
So these components kind of act like specialized translators, They make sure that the information is formatted correctly for the transformer to process.
Like interpreters that help different cultures communicate.
Precisely.
Okay.
And then you have the attention mechanism,
Oh.
which is super important for the transformer to understand those relationships between the different pieces of data.
Yeah.
So for text, it uses what's called causal attention,
Okay.
which basically means you can only look at the previous words in a sequence to predict the next one.
Like how we read. Building understanding as we go.
Right. But for images, it uses what we call bidirectional attention within each image.
Okay.
So every part of the image can see and be seen by every other part all at the same time.
At the same time.
This helps the model capture a much richer understanding of that visual information.
So there's a different approach to attention depending on if we're dealing with text or images.
Exactly.
Makes sense.
And that difference is really key to transfusion's ability to handle both those data types so effectively.
Right. So we've got this intricate dance of data flowing through the model with text and images being processed in this really integrated way.
Yeah.
But how does transfusion actually learn from all of this?
That's where the idea of dual objectives comes in.
Dual objective.
Language modeling loss and diffusion loss.
Oh, that sounds interesting. Tell me more.
So the language modeling loss is all about encouraging the model to accurately predict the next word in a sequence,
Okay.
which is pretty standard for how you train language models.
Uh-huh.
But then you've got the diffusion loss. Yeah. Which pushes the model to reconstruct an image from like a noisy version of it.
Oh, so like those AI art generators.
Yeah, exactly.
So it's almost like having two teachers with their own specialties working together to train a student.
Yeah, that's a good way to put it.
One focusing on the language skills and the other honing the artistic abilities.
And what's fascinating is that the overall training objective for transfusion is essentially just combining those two losses together.
Really?
You have what's called a balancing coefficient called lambda
Okay.
that controls how much emphasis is put on each objective.
Yeah.
But the core concept is surprisingly straightforward.
So it's all about finding the right balance between these two objectives to train the model effectively.
Exactly.
But does it actually work? Does transfusion live up to the hype?
Well, that's the real question, isn't it? And the results are pretty impressive. They really are. The paper compares transfusion to another model called Chameleon,
Okay.
which tries to represent images as tokens like words.
Right.
But transfusion consistently outperforms Chameleon across different tasks.
Really?
And it does so using way less computing power.
That's gotta be huge.
It's a big deal. It means that we can potentially get the same results, but using less energy and cheaper hardware,
Oh, that makes sense.
which is great news for researchers and developers who might not have, access to these massive computing clusters.
Right.
It could really democratize access to these really powerful multimodal models.
Yeah, that's really cool. And the paper mentions some pretty impressive numbers.
Oh, yeah.
Like, for example, transfusion needed 34 times less compute to get similar image generation quality as Chameleon.
34 times less.
Right.
That's measured by what's called an FID score, right?
Right, the FID score, or Fréchet inception distance. It's basically a way to measure how realistic and visually appealing AI-generated images are.
Exactly.
Lower scores are better.
Yeah.
And transfusion achieved comparable FID scores to Chameleon, but using significantly less compute.
Yeah, it's a huge win for efficiency.
Yeah, for sure.
Yeah.
But it's not just about generating images, right?
Yeah.
Transfusion also beats Chameleon at image captioning,
Oh, yeah, for sure.
where the model has to describe an image accurately using words.
Right. And it's pretty fascinating that transfusion can excel at both generating images and describing them with text.
It really shows how well it blends those two modalities.
Yeah, it really does.
And here's something I found really surprising. The research shows that transfusion actually outperforms Chameleon on tasks that just involve text,
Really?
even though it was trained on both images and text.
That is surprising. You'd think a model trained exclusively on text would have an advantage there.
Yeah, you'd think so, right?
But the results actually suggest that exposure to that visual information might help the model develop a richer understanding of language itself.
That's really cool. It's like learning a new language by immersing yourself in a culture where that language is spoken.
Right.
You pick up all those nuances and connections you wouldn't get just from studying a textbook.
Exactly. It opens up all these possibilities.
Yeah.
Perhaps multimodal training is the key to developing AI models that aren't just capable of handling multiple data types, but are also just more intelligent and adaptable overall.
Okay, so we've talked about how transfusion works.
Right.
We've talked about how well it performs.
Yeah.
But let's take a step back
Sure.
and talk about the bigger picture.
Okay.
Why should our listeners care about this?
Yeah.
What are the real-world implications of a model like transfusion?
Well, transfusion is more than just some cool technology.
Right.
It has the potential to revolutionize a lot of fields.
Okay.
I mean, imagine AI assistants that can understand and respond to both your words and the images you show them.
Oh, wow.
So they'd be way more helpful and intuitive to use.
Oh, that would be amazing.
Or think about what this could mean for artists and designers
Yeah.
who could use these models as creative tools
Ah,
to explore new ideas and push the boundaries of visual expression.
that's so cool. And the paper also mentions some exciting preliminary work on using transfusion for image editing.
Oh, yeah, that's really cool stuff.
Can you tell us a bit more about that?
Sure. So the researchers basically fine-tuned a transfusion model to edit existing images based on text instructions.
Wow.
So imagine being able to tell the AI something like, make the sky in this photo look like a sunset,
Oh,
or add a hat to this person,
yeah.
and have it make those changes seamlessly and realistically.
That would be incredible. It would totally change the way we interact with images
For sure.
and open up so many possibilities for creative expression and content creation.
And because transfusion is so efficient, We can expect these capabilities to get even better as the models get bigger and the data sets get richer.
So it's like we've unlocked a new level of AI,
Yeah.
and we're just starting to figure out what we can do with it.
Exactly. And that leads to a pretty interesting question.
Okay.
If transfusion can get these results with just images and text,
Right.
what happens when we start adding other modalities to the mix?
What do you mean by other modalities?
Well, what if we could incorporate things like audio, video, or even sensory data like touch and smell into these models? Could we create AI systems that can understand and interact with the world in a way that's even more human-like?
That's mind-blowing. It's like we're on the cusp of a whole new era of AI where those lines between the different modalities get blurry,
Right.
and our models become much better at perceiving and understanding the world in all its complexity.
It's a super exciting time to be working in this field. There's so many questions left to answer and so much potential for groundbreaking discoveries.
Yeah.
And it's not just about developing the technology itself either.
What else do we need to consider? What else is there?
Well, we also need to be having some serious conversations about the ethical implications of all this.
Oh, yeah, of course.
How do we make sure that these powerful AI tools are being used responsibly
Right.
and for the good of everyone?
It's a discussion we need to start having now.
Absolutely, especially as these models keep evolving so quickly.
That's a really important point.
Yeah,
We can't just create powerful tools.
right.
We need to make sure we use them to make the world a better place.
Exactly.
Yeah.
And I think one of the big takeaways for anyone who's following the development of multimodal AI is to really pay attention to those balancing coefficients.
Oh, those lambdas.
Exactly, those lambdas we talked about earlier.
Yeah.
They might seem like just technical details,
Right.
but they have a huge impact on how these models learn and what they're capable of.
Like fine-tuning the ingredients in a recipe
Precisely.
to create that perfect dish.
Getting that balance right is so essential.
Yeah, for sure. So as we wrap up our deep dive into transfusion,
Yeah.
what's the one big takeaway you'd want our listener to walk away with?
That's a good question. If combining language modeling and diffusion can lead to such impressive results,
Right.
it makes you wonder what other unexpected pairings might unlock even greater AI capabilities.
Yeah, what else is out there?
What if we could combine AI models that are trained on different senses,
Okay.
like sight, sound, and touch?
Wow.
We create a really holistic understanding of the world within these models.
Now that's a really thought-provoking question to end on.
Yeah.
It really seems like we're just starting to explore what's possible with multimodal AI.
Absolutely, and that's what makes this field so exciting.
Yeah.
There's just so much more to discover and so much potential to create truly transformative technologies.
Well, I think it's safe to say our listener's mind is buzzing with possibilities after this deep dive.
Hopefully so.
Thanks for walking us through all this fascinating research.
It's been my pleasure.
And that wraps up another deep dive. Until next time, keep exploring, keep learning, and keep pushing those boundaries of what's possible.